And so on Friday, right, we showed that this difference of squares, a squared minus b squared, factors into a minus b times a plus b. And we showed that by foiling the right-hand side, on the right-hand side equals the left-hand side. And then we talked about difference of two cubes, sum of two cubes, and a strategy that I use for memorizing those formulas. And then we got the binomial expansion when n equals 2, and the binomial expansion when n equals 3. So let's take a look at those formulas real quick like. So in the binomial expansion with n equals 2, right, we actually have two formulas here. One where you use the plus sign, and then one where you use the minus sign. So when we use the plus sign, what that says is we have a plus b squared. And then we use the plus sign on the right-hand side. A plus b squared is equal to a squared plus, right, we use the plus sign here, 2 times a times b plus b squared. Now you should be able to prove that easily enough, right, because a plus b squared just means a plus b times a plus b. And when you FOIL that, you get a squared plus 2ab plus b squared. Okay? So that's easy to prove, going left to right. And then right to left is true, right? A squared plus 2ab plus b squared is equal to a plus b squared. Now when we use the minus sign, we have a minus b squared is equal to a squared minus 2 times a times b plus b squared. Again, you should be able to show this, right, by foiling the left-hand side. A minus b times a minus b FOILs to a squared minus 2ab plus b squared. Okay? And you should be able to go from right to left, right? We reviewed factoring at the beginning of the semester. Okay? All right. And then we have the binomial expansion with n equals 3. So again, we use the plus sign on the left, and then we got to use the plus signs on the right. And we have a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Now you notice that when it's a plus b inside here and we cube it, all the coefficients are positive. Okay? The coefficients, I remember the number 13, 31. Okay? 1, 3, 3, 1. 13, 31. Okay? And we had the same thing here, right? When we square a plus b squared, right? All the coefficients are positive. Okay? Now, how I remember the right-hand side is the first term. Whenever you have a binomial raised to an integer power, the first term is going to be the first number. In this case, we have a, the first number is going to be a cubed, you see that. And the last number is going to be b cubed, and you see that. It's the middle two numbers, right? Terms that can be difficult to remember. And how I remember this formula is first the coefficients are the number 1331. And you notice in the first term we have a cubed, and then the second term a squared, third term a, and then fourth term is actually a to the 0, which is 1. So you see that the power on a decreases by 1 as you go from left to right. And the power on B increases by 1 as you go from left to right. B to the 0 is equal to 1. This is B to the first power. This is B to the second power. This is B to the third power. So descending, right, powers of A going from left to right, and increasing powers of B going from left to right. Okay. So those are like, that's how you memorize them, whatever works for you. But I look for patterns, and the patterns are what help me to memorize these things. Okay. And now if you replace the plus sign with minus, we have A minus B cubed, and the right hand side, again, the first term is A cubed, and now we have minus 3A squared B plus 3AB squared minus B cubed. So now it alternates, right? Plus, minus, instead of all the coefficients being positive. So there's a pattern between A plus B cubed and A minus B cubed. So look for the, I look for the patterns in memorizing these things, okay? So we're going to be using these formulas in this section, okay? And again, when you're doing the homework, right, you can look at your sheet, right, in solving the homework. But when it comes to the quiz and the exams, you got to know the formulas well enough to memorize them up here, okay? Are you with me? All right. So if you flip over to page 3, we're going to evaluate limits of what are called 0 over 0 form. And so again, I've set the remainder of this handout. The problems in this handout similar to how it's set up in WebAssembly. So in the first exercise, we're instructed to use factorization to simplify the given expression, then find the indicated limit. Okay. So what we're going to do is factor the numerator and the denominator, okay, and then cancel any common factors. So we have x squared minus x minus 6 over x cubed plus 8. Now, when it comes to factoring trinomials, we reviewed that at the beginning of the semester, didn't we? So you should be comfortable factoring trinomials. Okay. The numerator factors. Does anybody tell me what the numerator factors to?
3.
What?
X minus 3 and x plus 2.
Yep. X plus 2 times x minus 3. Now this guy is new to you, right? So, right, we're factoring, right, a sum of cubes. Remember, 8 here is equal to 2 cubed, right? So to factor the denominator, okay, we got to use, my finger, there it is, the sum of 2 cubes formula, right? X cubed plus 2 cubed is of the form A cubed plus B cubed, right? Where A is replaced with the number X and B is replaced with the number 2, okay? So we replace A with X and move down here. A with X and B with 2. And so then on the right hand side, we replaced A with X and B with 2. So X cubed plus 2 cubed factors into X plus 2. Right? I'm just putting in an X for A and a 2 for B. So we have X plus 2. And then when I put in an X here for A, I have X squared. Then I got to subtract. And then A is X and B is 2. And so X times 2 we write as 2 times X. Right? We switch the order of multiplication. And then B squared is 2 squared in this case. And 2 squared is equal to 4. So the denominator, right, factors into X plus 2 times X squared minus 2X plus 4 using the sum of 2 cubes formula. Okay? Replacing A with X and B with 2. Well, now if you look at this, you see there's a common factor in the numerator and denominator, right? X plus 2. So those two factors cancel under one condition. So those two factors cancel, and then we're left with X minus 3 over X squared minus 2X plus 4. And they cancel under the condition that X doesn't equal negative 2. Because if X equals negative 2, inside this factor here we have negative 2 plus 2, which is 0. And 0 times this is 0. And can you ever divide by 0 in mathematics? No. This is undefined if X is equal to negative 2. So X can't equal negative 2. Cool beans? All right, so now let's evaluate the limit. So this rational expression, right, simplifies to X minus 3 over X squared minus 2X plus 4 if X doesn't equal negative 2. You can see if you put in negative 2 in for X here in the bottom, negative 2 cubed is negative 8. Negative 8 plus 8 is 0. And you can't divide by 0. All right. So now let's find the limit as X approaches minus 2 of X squared minus X minus 6 over X cubed plus 8. Well, you know the first step in evaluating a limit is direct substitution, right? So when you put minus 2 in for X in the numerator, you have minus 2 squared minus 2 minus 6. In the denominator, you have minus 2 cubed plus 8. Well, when you do PEMDAS in the numerator, you end up with 4 plus 2, which is 6, and 6 minus 6 is 0. And we already know the denominator will equal 0. Minus 2 cubed is negative 8, and negative 8 plus 8 is 0. And so we have 0 divided by 0, which is undefined. So we already knew this from up here. This rational expression is undefined at X equals minus 2. At X equals minus 2. But the limit may still exist. Because remember, the limit tells us what value this rational expression is getting close to as X gets close to minus 2. So the closer x is to minus 2, the closer this rational expression is to a certain number. Okay? Even though it's undefined at x equals minus 2. Well, we know from up above, so this x approaching minus 2, we know from up above, if x doesn't equal minus 2, this rational expression reduces to x minus 3 over x squared minus 2x plus 4. This guy right here, we know from up above, reduces to this as long as x doesn't equal minus 2. And remember, in the limit, x is getting close to minus 2. It doesn't equal minus 2. Okay? And so even though the function is undefined at x equals minus 2, the limit may still exist. And now we do direct substitution. We put in minus 2 in for x. So we have minus 2, minus 3 in the numerator. And in the denominator, we have minus 2 squared, minus 2 times minus 2 plus 4. Well, the numerator equals minus 5. And the denominator, when you do PEMDAS, minus 2 squared is 4, minus 2 times minus 2 is 4, 4 plus 4 plus 4, which is 12. And so you can leave the answer as minus 5 over 12, or write it as minus 5/12, whatever makes you happy. So this rational expression is undefined at x equals minus 2, but we know that the closer the value of the x is to minus 2, the closer the value of this rational expression is to minus 5/12. For those of you that take Math 120, this is a very important concept. Okay? So spend all of exam 1 is basically this idea. Okay? Any questions, ladies and gentlemen, on this problem level? Okay. And don't worry, practice makes perfect. That's why you do homework. All right. So the next one involves a difference of cubes. Here we did a sum of cubes in the denominator. We're doing a difference of cubes in the numerator. So we have 8x cubed minus 1 over 2x squared plus 3x minus 2. So factoring the denominator should not be difficult, right? We know how to factor trinomials now. Okay? But in the numerator, okay, we actually have a difference of cubes. You know that 2 cubed is equal to 8, right? So 8 cubed can be written as, or 8x cubed can be written as 2x cubed, right? And by the rules of exponents, this is equal to 2 cubed, which is 8 times x cubed, okay? And this 1 here can be written as 1 cubed. So in our difference of cubes formula, from the previous page, our A in this case is equal to 2x, and our B is equal to 1. Right? You put in 2x in for A here, and so you get 2x cubed is 8x cubed. You put 1 in for B here, and you have 1 cubed is 1. So on the right hand side, wherever you see an A, you put 2x, and wherever you see a B, you put 1. Okay? So the numerator, the first factor is A minus B, which is 2x minus 1 in this case. And now you got to put in 2x in for A here, right? So A squared in this case
Oh, wait, I thought we were just plugging in 2x and 1 for x.
So we're putting in 2x for A and 1 in for B in the formula over here. Yes, ma'am.
Why is it 1 instead of negative 1?
From the formula, it's A minus B.
But, like, why is b 1 instead of negative 1? Because it's like minus 1?
Well, if B was equal to 1, right, then we would have 2x cubed minus a negative 1 cubed.
Oh, okay.
And a negative 1 cubed is negative 1. So 2x cubed is 8x cubed. And then we have minus a negative 1. And minus a negative 1 is plus 1. And that's not what we got. Okay. All right. So A squared, in this case, is equal to 2x squared, which is equal to 4x squared, right? Using the rules of exponents. And then we have plus A times B. Well, A is 2x, B is 1. So we have plus 2x. And then we have plus B squared. B squared is equal to 1 squared, which is equal to 1. So you remember the quadratic formula from high school? You had to plug in for A, B, and C. That's what we're doing here, right? Only it's A and B, just A and B we're plugging in for. Okay? So this is like using the quadratic formula, but the formula is different. Then we're just plugging in for A and B.
So when the signs are switched for difference and sum, like if it's a negative for the first part, and it will be a positive for the second part, like
Are you talking about here and here?
yeah,
Or here and here? Or both?
I guess both. Like how
So that's how I remember the formula. So A cubed minus B cubed begins with A minus B. And A cubed plus B cubed begins with plus B.
oh sorry, I was looking at the wrong one.
Okay?
Yeah, I'm good. Sorry. I
So
just
we're
myself.
doing a difference of 2 cubes up here. Okay? On the previous problem, we had a sum of 2 cubes.
Right.
Now we're doing a difference of 2 cubes.
Okay.
Yeah, I mean, it's going to take practice. I understand that. Okay. All right. So does everybody understand how all we're doing is plugging in for A and B on the right-hand side, like you plugged in for A, B, and C in the quadratic formula. Okay. The deal is, you guys probably solved 10,000 problems with the quadratic formula, and you haven't solved 10,000 problems with these formulas. Okay. All right. Now, factoring the denominator comes from first couple of days of classes, right? So, who can tell me what the factors are for the denominator? What do you got?
2x minus 1 and x plus 2.
Yep, 2x minus 1 and x plus 2. What's one technique you can use to find those factors? Who said X method? Right, she uses the X method. What's another method? Slide, divide, slide, right? And then what was the third method? Box method, right? So now I'm old school. You know, it was just trial and error, right? Until you found the right factors. But we spent 1.5 class periods at being semester, right, reviewing factoring trinomials, right? So that everybody would have a method for factoring trinomials. Okay. All right, very good. And now, do you see any common factors in the numerator and denominator? Yeah, 2x minus 1, right? Those cancel under one condition. What's the condition? X can equal 1/2. If this factor 2x minus 1 equals 0, okay, then you get 0 times x plus 2, which is equal to 0, and you can't divide by 0 in mathematics. So to get the 1/2, you can set 2x minus 1 not equal to 0, and when you solve for x, you get x can equal 1/2. So this reduces to this if x doesn't equal 1/2. Okay. All right. So now we can evaluate the limit. We have the limit as x approaches 1/2 of this rational expression, 8x cubed minus 1 over 2x squared plus 3x minus 2. Now, on an exam, ladies and gentlemen, I may not have this broken up into 2 parts. I may just have to ask you, what's the value of this limit? And then you got to do the direct substitution, and you're like, oh man, it's 0 over 0 form. So now I got to factor the numerator and denominator, cancel out common factors. Okay. So you know the first step is direct substitution. So when I put in 1/2 in for x, I have 8 times 1/2 cubed minus 1 over 2 times 1/2 squared plus 3 times 1/2 minus 2. Now you gotta do PEMDAS, right? 1/2 cubed is 1/8. 8 times 1/8 is 1. 1 minus 1 is 0. So the numerator equals 0. Denominator, PEMDAS, 1/2 squared is 1/4. 2 times 1/4 is 1/2. 3 times 1/2 is 3/2. 1/2 plus 3/2 is 4/2, which is 2. And 2 minus 2 is 0. So you can verify that both the numerator and the denominator are undefined. Or excuse me, the numerator is 0, denominator is 0, and 0 divided by 0 is undefined. So this rational expression is undefined at x equals 1/2, but the limit still may exist because x doesn't equal 1/2; it just gets real close to it. Okay. Yes, ma'am.
When does the limit not exist?
we're actually, when you take Math 120, you will get exposed. If you have to take Math 120, we'll be dealing with that situation, but not in Math 111. Okay. All right. So x doesn't equal 1/2, just gets close to it. So this rational expression from up here, or this rational expression reduces to this up here, because x never equals 1/2. And so this limit as x approaches 1/2 of 4x squared plus 2x plus 1 over x plus 2. And now we can do the direct substitution. Put in 1/2 in for x. We have 4 times 1/2 squared plus 2 times 1/2 plus 1 in the numerator over 1/2 plus 2 in the denominator. And now when you do PEMDAS in the numerator, 4 times 1/2 squared is 1. 2 times 1/2 is 1, so we have 1 plus 1 plus 1, which is equal to 3. And the denominator, 2 plus 1/2 is 2 and 1/2, which is the same as 5/2. And we reviewed division with fractions at the beginning of the semester, right? This is equal to 3 times 2/5, right? Keep, switch, flip, remember? And you end up with 6/5. So the closer x is to 1/2, the closer the value of this rational expression is to the number 6/5, even though this rational expression is undefined at x equals 1/2. Okay? So the difference between at and near.
So would we get points off if we had put 3/25 instead of like 3/?
Yeah.
Okay.
Because I'll write on the exam no decimal answer.
Okay.
Okay? All right. So let me get attendance.